Okay, can everybody see my presentation?
Yes, ma'am.
Okay, so now tell me, this slide was visible. I mean, did I complete this slide or not? This slide, making routing scalable.
No, ma'am, I think from starting it got disconnected.
Oh. Okay, so what is Arvind Lenin wanting? He's asking for control. What happened? Arvind Lenin, do you have anything to say?
Actually, I pressed by accidentally. I pressed it.
Okay. Okay, so I'm sorry for all these issues. I didn't know that this was happening. Anyways, um, all right. So in that case, I will start with inter-AS routing that we had started in the last class. Okay, although I gave a full revision just before that without knowing that the call had dropped. So basically, we are going to start with intra and inter-AS routing. Okay, so intra-AS routing is where we are having the routing amongst routers that belong to a given AS. Okay, whereas inter-AS routing is the kind of routing where you are basically communicating, or a router is basically communicating with another router which belongs to any other AS. Okay, AS we already know from last class that it is nothing but an autonomous system, which is nothing but an aggregation of routers that belong to a given region. Okay, now what happens in intra-AS? So here the network administrator, he can take control and he can actually control that what routing protocol should be used in that case. Okay. So in that case, if an intra-AS routing has to be used, so it is always a simpler way or an easier way that all the routers that belonging to a given given AS, they should follow the same intra-domain protocol, right? They should follow the same intra-domain routing protocol. Okay. So what will happen? Different ASs, they can run different intra-domain routing protocols or intra-AS routing protocols, but within the same AS, the same routing protocol will be used. Okay. Now, if there has to be a communication between a given router in an AS and another router in another AS, so in that case, the routers which are basically acting uh, as the gateway router or a bridge between one AS and another AS, those are nothing but edge routers and they are called as gateway routers. Okay, so they act as a link or a bridge between one AS and another AS. Okay, so you can think of the amount of complexity that is handled by a gateway router, because it is the one that is a part of the intra-AS router. It is controlling or it is giving out the information uh, to different routers that belong to the same AS, and it is also helping all the other routers belonging to an AS to communicate with any external router belonging to any other AS. Okay. So that's about gateway routers. So let's just pictorially see about ASs. So here we have different ASs, that is AS1, 2 and 3. Within the same AS, we have the same kind of routing protocol, that is an intra-AS routing protocol. Different ASs can have their different intra-AS routing protocols. Between different ASs, whenever we are routing, it is known as inter-AS routing, and that is done with the help of gateway routers. Okay. Now, how does a gateway router get get information about which packet to send to which port? So that is, we know that any router gets that information from its forwarding table. but the entries in the forwarding table are basically influenced by the intra-AS routing protocol that is used within the AS and the inter-AS routing protocol that is used in the network. Okay, so for internal destinations, the entries will be influenced from the intra-AS routing or taken from the intra-AS routing, and for external destinations, the entries will be filled up using the inter-AS routing protocol. Okay, so now inter-AS routing. Okay, so suppose a router in AS1 receives the datagram that is destined outside of AS1. So suppose this 1A, this router, it receives any datagram that has to go out of AS1, somewhere outside it. Now 1A does not have any connection to any outside router, right? So what it does, it has to first know that where it should forward the packet, or basically it has to forward the packet to the gateway router of AS1. But which gateway router? There are two gateway routers here, one C and one B. Okay, so to which gateway router it should forward the packet to? Okay, so in order to do that, what it should know? That it should know that which destinations are reachable through AS2 and which destinations are reachable through AS3. Okay, so that means that will give it the information that to which gateway router it should send that particular datagram to, or forward that datagram to. Okay, now this information, that which destinations are reachable through AS2 and which destinations are reachable through AS3, that information has to be propagated to all the routers belonging to the given AS. Now let us see what are the different types of intra-AS routing protocols. Okay. Now different types of intra-AS routing protocols. The most common one is RIP, or Routing Information Protocol. It uses distance vector routing protocol, and the classic distance vector routing protocol, where the information is exchanged between the distance vector information is exchanged between different routers periodically every 30 seconds. Okay, it is no longer widely used, but if you still want to go ahead and take a reference of it, then you can go and check RFC 1723, where you will get the information about routing information protocol. Now the next protocol is EIGRP, or Enhanced Interior Gateway Routing Protocol. Okay, this is also a distance vector based protocol, and it was formally basically it was proposed by Cisco, and it has been Cisco proprietary for a long time. Now it's open from 2013, and you can find it in RFC 7868. Now, this is one of the important ones. We had started with this. If you see the contents, when we had started this slide, for intra-AS routing, we have started that we will check OSPF. And OSPF is nothing but Open Shortest Path First. Okay, and the corresponding RFC is 2328. OSPF uses Link State Routing Protocol. It is also known as the IS protocol. Okay, basically, it's not that OSPF is known as the IS protocol. They both are basically similar protocols. Okay, so they can sometimes be called in exchange of each other, but anyways, they are different protocols, OSPF and ISIS protocol. Um, it is not, ISIS is not, does not belong to any RFC standard. It is just an ISO standard for an intra-AS routing. Okay, so when we will be studying about intra-AS routing protocol for this, we will be studying only about Open Shortest Path First, okay, which is a link state routing protocol. Okay, so let's start with OSPF routing. Okay, so everybody can hear me, or everything is fine with the connection now?
Yes.
Yes,
Okay, okay,
ma'am.
fine. Okay, all right. So open shortest path routing protocol. Okay. So why it is called open? Um, it's said that it's kind of publicly available. How? We are using a classic link state protocol here. Okay. So when we use link state routing protocol, what are we doing? We are basically uh, allowing all the nodes belonging to the network to know about every other node. Right? So the information about the entire network topology is known to all the nodes in case of link state protocols. So how does this link state information exchanged with any other router? In this case, each router floods the link state advertisements to all other routers in the entire AS. Okay, because it is an intra-AS, so within the AS, each router floods its own link state advertisement to all other routers in the AS. How is it flooded? It is flooded directly over IP rather than using TCP or UDP. Okay. Now, there are multiple link cost metrics that are possible in this case. Mostly use are bandwidth and delay. So we know that by flooding this information, the link state information, each router will have full topology of the entire network, and then they can simply use Dijkstra's algorithm to compute the forwarding table. So the only change that OSPF provides, apart from just simply using the link state algorithm, is that all OSPF messages provide a bit of security by authenticating the datagrams. Okay, so that malicious intrusions can be prevented. Alright. Now, if you check that if we see any diagram here, we are seeing that any AS is basically consisting of a few routers, and those routers can be flooded with all the link state information, and that information can be sent across, or continuously they can be periodically flooded, and all the routers will know the information of all other routers. But if you think from the perspective of having billions and billions of nodes in a given network, so in a given AS also there will be a large number of routers and large number of nodes, right? So in that case, if we still want to use link state algorithm there, it will become a very cumbersome process. Okay. So in order to make it somewhat easier, hierarchical OSPF was proposed. Okay. So what is hierarchical OSPF? So nothing but you are basically creating a hierarchy so that the link state advertisements are flooded in a smaller area. Okay. So firstly, we will study about the two-level hierarchy of OSPF. So how do we do a hierarchy here? So you within the AS itself, you are making a backbone level and a local area level. Okay, there can be several local areas as you can see in this diagram. Area 1, 2, and 3. There are 3 local areas, and you have a backbone area. Okay, so the link state advertisements can be flooded within each area or a given area, or it can be flooded over the backbone. Okay, so now you can ask me the question that in that case, how link state will be possible, because nodes will not be knowing any other, topology of information of any other network. So essentially, we are basically making a network of a set of routers within an area, right? So if any link advertisement is flooded within that area, they will be knowing the structure of that given area, right? So area topology is known for every node. Okay. Only thing that is needed extra is that the each node being a router here, each node has to know the direction to reach the other destinations. Okay. You just need to know that in order to reach to area 2, what should be the direction in which the datagram should be moved to. Okay, so only this additional information is needed in this case. Okay. So how is this information given out? This is done using this area border routers. Okay. So what is their task? Their task is to summarize distances to destinations in the own area and advertise this information also in the backbone network. Okay, so backbone of this same AS. Now within this area 1, we have local routers. What do? They flood the link state information within their area only. They compute routing within a given area and they forward packets to outside area via the area border router. Okay, so this is the area border router. So essentially, if you see, this is also kind of AS within an AS where we have again a kind of a gateway which is trying to connect or which is helping or bridging between one AS and the backbone here. There, in case of when we were looking at the AS on the whole, then the gateways were basically allowing to communicate between one AS and another AS directly. Then what we have is the boundary router, which is the one which will connect this entire AS to any other AS. So this is exactly this boundary router is the gateway router that we have seen in previous slides. And the other ones which are here, those are backbone routers, which help in running the OSPF protocol, which is limited to only the backbone. Okay. So that was about OSPF, which is an intra-AS routing protocol. Okay. Now we are going to study about inter-AS routing protocol. Okay. How does routing happen among different ISPs? Okay. And the routing protocol that we are going to study is BGP or Border Gateway Protocol. This is a very important routing protocol and very interesting also. Okay. So, Border Gateway Protocol or BGP is the de facto inter-domain routing protocol. Okay. It is generally used as an inter-domain. I mean, in current scenarios, it is generally used as an inter-domain routing protocol and is also known as the glue that holds the internet together. Okay. So you have different ISPs. How do they communicate, or how do they do routing within each other, between each other? So that is done using BGP. So if we have to do that, if you think from the perspective of an ISP and then hosts, how the hosts are generally connected in a network, the first thing that will come to your mind is that subnet, right? All the hosts are basically connected as different subnets. Okay, so every subnet has to tell or inform the network that it exists, right? So what this BGP allows is that it allows the subnets to advertise their own existence, and also the destinations are those are reachable through that within that subnet. Okay, so basically the subnet is basically telling about its existence and also about the hosts that are connected to this particular subnet. Okay, and this information is communicated to the rest of the internet, and how it is done that we will see. So, what does BGP do? Okay, BGP basically provides each AS a way in which it can, number one, obtain the subnet reachability information from neighboring ASs. That means which subnet can be reached from which AS, and then propagate this reachability information to all the routers which belong internally to a given AS. Okay. So sending or communicating the information about subnet reachability from neighboring ASs, this is done using kind of message which is known as eBGP or external BGP, and propagating reachability information to all the internal routers in an AS, that is known as iBGP or internal BGP. Okay, so this is done so that good routes to other networks are found out based on the reachability information and the routing policy. Okay. Now let's see what are these eBGP and iBGP connections. Okay. eBGP between different AS. Okay, that is the connectivity between different ASs, and iBGP is logical connection between. I mean, here it is shown as a logical connection. iBGP is used within the given AS. Okay. Now, how does this BGP work? So the gateway routers that are here, which have been circled here, they run both eBGP and iBGP protocols. Okay. So how does BGP work? Whenever a BGP session starts, we will have two BGP routers that will exchange BGP messages over semi-permanent TCP connection. So, can somebody tell me why are we basically looking at a TCP connection here? We could have a UDP connection, right? Why are we having a TCP connection in this kind of a network? Any thoughts on this?
Probably because TCP is a duplex um, protocol. It establishes a duplex network.
That's true. Anything else? Nothing else. Just simply the properties that TCP provides, right? You are basically talking about transferring your data through a given set of routers with the objective that you want to achieve certain kinds of facilities or quality of service properties, right? So BGP uses TCP for its security issues. I mean, for the way that it provides the security, which is not provided by UDP at all, and also for all the other QoS related properties that TCP basically provides, apart from the duplex one that you are talking about. Okay, that's also one of the issues. Okay, now let's get to how the BGP session basically works. Okay, so when two BGP routers try to exchange BGP messages over a TCP connection, what are they basically exchanging? They are firstly they are advertising the paths to different destination network prefixes. Okay, so here it is. So this is a particular destination. Okay, X is a particular destination that's there. Now, when AS3's gateway, that is 3A, it advertises the path that if you want to reach X, you have to go through AS3. Okay, this is the BGP advertisement that is being advertised by this gateway AS3 to its nearby gateway, which is 2C of AS2. Okay, so what it does essentially AS3 is what it is doing that if there is some datagram that has to be here in AS3, then AS3 will promise to AS2 that it will forward the datagrams towards X. Okay, so this is what the BGP advertisement is telling about when it is sending this path information of X to 2C, that is that is again a gateway router of AS2. Now, what is basically advertised using these BGP advertisements? Okay, so one is BGP advertised route. Okay, so what is that? Prefix plus attributes. Okay, prefix is what? What is the destination that is being advertised? And two important attributes. That means first is AS path. That means the list of ASs through which the prefix advertisement has already passed by now, and the next hop information, that is which router that is specific to the internal AS router, that is to next hop AS. Okay, so next hop will indicate the specific internal AS router to next hop AS, and AS path will basically send, or it will inform about the list of ASs through which the prefix advertisement has already passed. Okay, so this is one set of advertisement that we are looking at, which contains prefixes plus attributes. Now, when we had started with BGP, we had said that whenever we are using BGP, okay, so this eBGP and IBGP is done according to a policy of routing. Okay, so what is this policy-based routing that is being used here? So first is that the gateway that receives the route advertisement, it uses import policy to accept or decline path. Okay. So for example, never route through a given AS. Okay. So nothing but the gateway is receiving some route advertisement, and then it is from this advertisement it is taking a decision, that is whether to accept the given path or to decline a given path. Okay, that is one. So we have different policies for these. I mean, we are using different policies for routing the information. Next is AS policy, which determines whether to advertise the path to other neighboring ASs. Okay, so policy-based routing is nothing but taking a decision depending upon what information you are getting through the advertisements that are being transferred to a given AS. Okay, so for example, if the gateway receives a given route advertisement, and with that advertisement it simply had to take this decision, that is whether it can accept the given path or it can decline the given path. And the other one is that given the advertised path that has been sent, okay, so what is the path to the neighboring AS? Okay, so this is what the policy based routing basically helps us to get the information. Now let's see how the BGP path advertisement works. So we are seeing diagram here where X was basically here. Okay, so when this advertisement was sent from 3A of AS3 to 2C of AS2. Okay, so here as you can see here, AS2 router 2C receives path advertisement AS3X, that is this one, via eBGP from AS3 router 3. Of course, it will be eBGP because it is between different ASs. Now, when this advertisement is received at 2C, depending upon the policy that is used in AS2, okay, then 2C will take a decision, that is whether it will accept the path or whether it will decline the path. In this example, 2C accepts the path AS3X, and after it accepts this path, it informs all other routers belonging to this particular AS about this new information that it has received about X, which belongs to AS3. And how is this message propagated? This is propagated via IBGP. Okay, so these are different sessions of transmitting information. External is between or eBGP is between different ASs. IBGP is between the routers belonging to the same AS. Okay. Now, depending upon this AS2 policy, what will AS2's next gateway router, that is 2A, what it will do? It will then again advertise the information that if one has to reach X, which belongs to AS3, one in the sense AS1, then what it has to do, it has to go via AS2, right? So 2A sends the information to 1C, that is AS2, AS3, X. Okay, so this is the path that is being sent from 2A to 1C, which is the gateway router of AS1. Again, the same thing will happen, that is at 1C, depending upon what is the policy that is being used within AS1. Accordingly, the path will be either accepted or it will be declined. If it is accepted, again via IBGP, the information will be propagated to all the routers that belong to AS1, and so on and so forth. Again, from the gateway router of AS1, again the information will be propagated, and so on. It will continue like that. Okay. Now, what happens if you have multiple paths to a given destination? Okay. So in that case also the router will definitely get to know that there are multiple paths to a given destination. So like here you have direct connection between 1C and 3A, that is AS1 and AS3 are connected directly. And as was given in the previous slides, that there is a connection from AS1 to AS3 via AS2. So we have already seen that if it is via AS2, then how path information is being propagated. Okay. Now this information to 1C about X is propagated from 2A of AS2, that if 1C, I mean any datagram for 1C has to reach X of AS3, then the path is via AS2, AS3 and X. So that is the path information that has been propagated from 2A to 1C. So 1C learned this path from 2A, and 1C also learned about the path to AS3 via 3A, and that path information is AS3, X. So 1C is learning two different paths to the same destination. Okay. Now what will 1C do? 1C, of course, there is a policy for the given AS. So depending upon what policy has been used, the AS1 gateway router, that is 1C, it will choose the path. It can choose AS2, AS3X or AS3X, depending upon what is the metric that you are using and which metric is lesser for you or best for the given AS, right? So here, as an example, it is considered that AS3X is the chosen path. Okay, it is better than AS2, AS3X. So 1C will now make this decision, will choose AS3X and then propagate this information to all the other routers belonging to this particular AS via IBGP. Clear? Okay. Hmm. So, as was told earlier, that BGP messages are exchanged between peers over TCP connection. All right. So, when we are talking about TCP connections, so how are these messages being exchanged? So, first step is open. That is, it opens TCP connection to remote BGP peer and authenticates sending BGP peer. Okay, so this is the first step. What's the second step? Update. So in this, new path is advertised, okay, or it is informed that the link has been destroyed or there is no link that belongs there within a given node. So whatever information was there, that information about this link needs to be withdrawn. Okay, so that advertisement also has to be sent. So that is also a kind of update. So in this step, new path is getting advertised or withdrawing of old path, that is getting informed. Then the correction has to be, of course, kept alive. Okay, so then the third step comes out as keep alive, where the connection is kept alive in the absence of updates, and also uh, acknowledgements of open requests are given out in this one. Okay, so this is the third step, and the fourth one is notification, where if there is any kind of error in the previous message, or if the connection needs to be closed, then those are communicated in this particular step. Okay, so that is notification. Okay, now let's take a look at BGP path advertisement. We have already seen this example where one C advertises the path AS3X to all other routers belonging to its AS. Okay. So look at the link interfaces that we have for router 1A. Okay, router 1A has link interface 1 and 2, and 1D has interface 1 and 2 like this. So this is the forwarding table here. So if one has to go to destination 1C, or if a datagram is basically it needs to go to destination 1C, then the interface is 1. And once this 1D, it is receiving this advertisement of AS3X, what is it putting in its forwarding table? That if one has to go to destination X, the interface that it has to use is 1. Okay? Alright. So how is this information being sent? So we know that within the AS, okay, we use intra-domain routing, and outside the ASS we are using inter-domain routing, right? So at 1D, what's happening? OSPF intra-domain routing is used to get to 1C using interface 1. So if there is any other packet that has to be transferred, okay, from 1D, so if it wants to get to 1C, then OSPF is used and packet is or datagram is forwarded via interface 1. Okay, and if it has to go to X, if it is destined to X, then also the interface 1 is being used to forward the particular datagram. Similarly, at 1A also, if the information is to be sent to 1C from 1A, then also OSPF intra-domain routing is used and the information is sent via 2, interface 2. Okay, and also if the datagram is destined to X, in that case also the interface 2 is used. Okay. Now the question is, so I'll take just 1 or 2 more minutes because I've lost some time in the beginning of the class. So why do we need different intra and inter-AS routing? Okay, so see, inter-AS routing, what will happen? The admin wants control over how its traffic is routed, who routes and through who routes through its own network. Okay, so that is about inter-AS routing. And intra-AS routing is that there is a single admin, he can control as to um, what policy will be used within that given AS. Okay, so policy wise, intra-AS routing becomes much less complex as compared to inter-AS routing. Okay, so if you have both as same, okay, so in that case things will become more complicated. You have to actually control using the same policies, same set of policies. You actually cannot control what happens inside the AS and what happens when you are trying to communicate between different AS. Okay. Next is of course the scale, right? So even though the hierarchical routing saves the amount of the size of the table that will be propagated between different routers, and it will reduce the updated traffic, but still the amount of nodes that are there in the system or there in the network, that is too high. Okay, so scalability is one issue, so that we have different intra and inter AS routings, and of course the performance. Okay, so in intra-AS routing, one can focus on how the protocol is actually performing. So one can focus on the performance. But in case of inter-AS routing, the policy matters more because, see, for inter-AS routing, the admin has to take control or has to know that over how the traffic is basically routed within this entire sets of ASs. Okay, who is routing through the given network, who is routing through which network. So that information is much more necessary. So policy dominates over performance when it comes to inter-AS routing. Okay, so the next one is a very special kind of a routing technique, and it's known as hot potato routing. But I think I'll take this one in the next class because we are already over time. So let me finish the class today here. Let me stop here. If you have any questions, you can ask. Otherwise, I will leave.